Awesome. I think some folks are starting to trickle into the call. Give it another minute or two. Awesome. Thank you so much for everyone who's joining. Thank you so much to those of you who joined us last month. Give it another 20 or 30 seconds or so, and then we'll go ahead and get started. I'm really excited to have everyone in today and have some great SMEs on. So grab your cup of coffee, grab your cup of tea. Let's go ahead and get going. Awesome. It looks like most people have started to trickle in. Awesome. Well, let's go ahead and get started. So this month we have a really exciting session. I have Sudarsan back on. He's been with us a couple of times. So those of you who have joined us in previous months, this will be a familiar face. And then we have Siban coming all the way from India, joining us today. Really excited to have him on and share some of the work he's been doing on our Kubernetes and container security side. So yeah, without further ado, let's go ahead and get started for today. So I want to start with some introductions. Sudarsan, you've been on before, but why don't you share a little bit about yourself? Share your background.
Thank you, Jeremy. Happy to collaborate again with you in a different forum. Thank you very much. Pretty excited. I've been here in Uptycs for a couple of years now. Prior to that, I've been in the security space for the last 15, 20 years across different segments of security, IAM, endpoints, now managing Kubernetes and the cloud security portfolio of Uptycs.
That's awesome. Yeah, you really have a wealth of experience. I'm excited for you to share some of the stories and some of the customer experiences that you've had with us. So I'm excited to have you on again. Siban, why don't you take a moment, introduce yourself to everyone?
Yeah, hi everyone. So this is Siban. So I'm with Uptycs from last 1.5 years or so. So I lead the Kubernetes security initiatives and the shift left initiatives at Uptycs. And in the past, broadly, I have majority of experiences in security domain. So more than 10 years into security. So that's pretty much about me. Thank you,
That's
Jeremy.
awesome. Yeah, no, this is fantastic having you both on. For those of you who don't know, Siban is carving out some expertise in the Kubernetes and container space. So it's really great to have someone like him on here to help explain why we're building things and how we're building them. So with that in mind, I'm going to give a quick overview of where we're going today. So we just did the introductions. Thank you so much to both of you. But yeah, I want to spend kind of the next 10 minutes really diving into what are RBAC policies in Kubernetes? Why are they so complex? How do we start to simplify and monitor them? And really just have this discussion around this space. Then after that first 10 or 15 minutes, we'll move more into a solution walkthrough. I think Siban will walk us through some of the actual tangible ways to take action and investigate these risky configurations. And then for the last 5 minutes or so, we'll just kind of open it up for some Q&A. So without further ado, let's go ahead and get started. Just to kind of give everyone a level playing field, Sudarsan, what really is Kubernetes? What actually is this world of Kubernetes and containers?
Yeah, I mean, if you think about the evolution, we moved from the monolithic architecture to more microservices architecture, right? So from a business perspective, a lot of prospects and customers, or even any organization for that matter, they want to do app modernization. When you think about app modernization, what it means is basically converting the monolithic to microservice architecture. The moment you talk about microservices, then containers comes into the picture, right? These are all purpose-built specific units of what do you call? I wouldn't say compute an image or which is designed for a specific purpose. Like if you want to run only web server, it will only run web server. If you want to run only a specific component within a web server, it will only run that, right? So containers, the challenge with containers is you have to somehow manage them from a security angle, from a network policy angle, from a access control angle, whatever angle you take, you need to manage them. Kubernetes is just an abstraction layer on top of containers that helps you to manage and orchestrate the entire container capabilities, right? But that's what Kubernetes is about. When it comes to RBAC, the biggest RBAC is not new. It's been there age old across any security organization, right? It's if you take cloud, if you take on-premise, if you take Active Directory, if you take it applies to everywhere. Everywhere that you have compute and network and storage, you need to have RBAC control in place. RBAC is nothing but role-based access control. based on what a customer wants to do or a prospect wants to do around what the user or identity or a subject wants to do, what kind of access they need to have, whether a specific subject or an identity can access a specific resource, right? That's all RBAC is all about. But RBAC is a core security capability that any organization should have in any attack surface that they are trying to protect. So I'll stop there. I want to hear from Siban's point of view because he has also a lot of expertise on that space. And Siban, what do you think on the RBAC and why it's important?
Yeah, I'll add one point to that, right? So what Sudarshan is saying. So for example, let's say you do not have RBAC in place in your Kubernetes environment, and there is one attacker in your environment. So if there is no RBAC in place, so what happens is the moment the attacker gets hold of an account, a service account, so he can use the service account, and by default, the service account will have access to everything inside the cluster because there is no RBAC in place. This is default service account, right? So with RBAC, what we can do, right? First thing is we can restrict the attacker have access to all the Kubernetes resources within the cluster. First thing. Second thing is, let's say, the attacker is trying to do any malicious activity. That attacker is, let's say, trying to exec some code or let's like escalate the privileges, etc. For him, so that he can do more damages to the organization. Because the impact will be huge, right? So in this case also, like if you have proper RBAC in place, the access can be controlled of the attacker, right? Because he doesn't have enough privileges, so he cannot do much damage. So first thing is like the attacker, even if he is inside, he cannot do much damage. So that is why basically the RBAC thing is very, very important. Yes.
No, this is perfect. Also, I had so many questions prepped and you guys just answered all of them in the first 5 minutes. So thank you so much for just kind of walking through those first few questions around like not only what is Kubernetes, what is RBAC, but really, Siban, giving us that example of how an attacker might be limited by strong protocols around RBAC or a good implementation of RBAC policies. So I do really appreciate all of that. One question I do have, just kind of stepping back a little bit. So role-based access control is kind of about the identity side of these Kubernetes and container relationships. I'm curious, Siban, maybe you could explain a little bit of how RBAC for Kubernetes is maybe a different problem to solve than traditional RBAC. Yeah.
Yeah, see, traditionally the RBAC is RBAC by default. Sorry about that sound. So RBAC by default is complex, right? So eventual goal is to have some kind of RBAC security model where you have minimal set of privileges for all of your users, so that just the right amount of access all your resources, all your users will have, or any Kubernetes resources or any resources, right? So for that, you need to do continuous auditing. You have to see what if the relationships are or if somebody has enough accesses, if anybody has more than sufficient accesses, things like that you have to audit continuously. But in Kubernetes case, so first thing is you have a black and white CLI, right? The command prompt. That is why you basically create all the basically the RBAC concept, like the roles, the role bindings, or cluster role binding kind of thing. Everything you create on that. So you over time, you do not know what is happening in the background. So over time, it will be very, very difficult to audit it. Right? This first thing, and the second thing is the process of creating it manually, right? There is a CLI and you create manually. So there is there is a role. You write one YAML file. You basically specify, okay, this is the namespace, and these are the different things that you can do as part of that role, right? And same thing, to bind the role to a user, you have to create a role binding. And then role binding is again, you basically want to limit that to a particular namespace, right? Again, if you see, the moment you for each of your application, you tend to create more roles, more role bindings, etc. And there is one more concept called cluster role and cluster role binding. So you do not want to limit your roles or role bindings to a particular namespace. In this case,
what is the difference between a role and a cluster role? I just want to make sure I understand a little bit of how Kubernetes is kind of defining these two different pieces here.
Yeah, so roles is basically, you want to provide certain permissions and restrict the permissions within a namespace, right? For that, roles are created. And the cluster role is you want to provide certain accesses or permissions and certain resources, but you do not want to limit that within a namespace. So that is when you create cluster roles.
Awesome. So that totally makes sense. So role would be kind of like a smaller scope, and cluster role would be kind of like this wider
Absolutely.
scope, higher cluster.
No restrictions across the cluster.
That definitely makes sense.
One thing that I want to touch upon that Siban talked about, right, the auditing, right? The biggest challenge in Kubernetes or even any cloud environment is the complexity of the relationship that is created because of these roles, cluster roles, and then bindings. Having that visibility is very important for any organization, right? To Siban's, like if you just go through the CLI, you create a lot of roles, cluster roles, and all that, but over a period of time, as an administrator, you kind of lose track of what else you have in your environment. That auditing topic that he talked about, having that visibility is absolutely critical as the first step. And then you talk about customers should think about how should I get to the least privilege, right? The permissions that Siban talked about. Least privilege is an absolutely important part where you can reduce the blast radius. If something is compromised in your environment, at least you can limit the damage an attacker could take based on the least privilege. That's something that's very important for an organization to go through.
No, and you guys have touched on it a few times over the last 10 minutes, just the idea of the complexity of these relationships. And I know in a few minutes, we'll look at this kind of visualization of that complexity. But I think it's really important that we hone in on this idea that Sudarsan, you have talked about a few times, kind of on these webinars and over a blog, the idea of who can access what. And that is really kind of the core of these RBAC policies, right? It's defining either from a human or a service account, who is able to access and touch and modify what. So I don't know if you want to expand on that a little bit. But...
Yeah. So Siban and I used to talk about this a lot, right? At the end of the day, IAM is all about two questions. Number one, given a user, like it's a Siban or myself or you, what kind of damage we can create in an organization? How do I get that answer to that question in the Kubernetes context, right? You can drill deeper around namespaces and all that, but that's a very core question businesses need to ask themselves. If there is an insider threat or if there's something happening, how do you know who can access what? That's the first one. The second one is if it's a critical resource, let's say there is a critical application running on a pod on a specific cluster or namespace, how do I know who all can connect to that specific pod? What all identities or subjects can connect and what kind of access do they have? Those are the two primary questions that any organization should ask when it comes to IAM, and RBAC layer built by Kubernetes addresses it. And we here at Uptycs help you give that visibility, provide you that risky configuration that Siban talked about, how we can help you prioritize the risk when it comes to protecting your RBAC implementation of Kubernetes.
No, that completely makes sense. I'm curious though, what are we actually hunting for when we're looking at, say, like a risky configuration? You know, Siban, what would a risky configuration look like? What would a risky relationship look like for you?
Well, I'll shortly demo the same thing on the UI, but one of the common examples in the industry is there is something called exec into a container, right? So let's say you want to change something in the container, right? So you want to debug a container, okay? Yeah, basically what happens is in the production directly, you provide exec into access to one of the developers or the DevOps guys. They go into the container, do some changes so that everything works properly, or they do debug, etc. But now in certain cases, let's say the attacker is inside your container or the pod, right? They take advantage of this particular privilege and they try to exec into your container, okay? So let's say using exec into this particular permission.
And just to clarify for everyone, he's talking about the exec command. Yeah.
Yes.
Right.
Yes.
Yeah.
And so let's say they download some malicious code and run some malicious code. So that's it, right? So once the malicious code is run, that means like the impact is done, the damage is done, right? And using the exec into, they can do a lot of things. They can mount hosts, they can mount secrets, they can create backdoor containers, They can create privileged containers as well. And so basically there are a lot of different things they can do just by starting from exec into privilege. So yeah, this is one of the examples of risky configurations that we're talking about, Jeremy.
Yeah, no, that's awesome. In fact, why don't we take a moment now and feel free to share your screen and we can start to walk through some of what it might look like to kind of build these relationships together or just kind of see them visualized.
Okay, perfect. Give me 1 second. I'll share my screen.
No worries.
Okay, do you see my screen?
I do. It looks great on my end. Sudarsan, can you see it?
Okay.
It looks perfect. Go ahead, Siban, yeah.
Okay, so this is our Kubernetes overview, Uptycs Kubernetes overview. So we'll go to Access Monitor, the feature that we are talking about, this particular feature. When I click on it, this is a landing page. So by default, it shows like all your clusters and some KPIs about your overall RBAC model, right? How many cluster roles are there? How many cluster admins are there? How many service accounts are there? And how many roles, etc. At the whole infra level, at the whole Kubernetes level, right? So all these styles that you see, these are all clusters. And here we saw KPIs at cluster level. Like for example, in contest QA, how many cluster roles are there? How many users, how many service account, how many roles are there? Okay, so once you click on this thing, you go inside, this is where the magic happens. Okay, so what you see is basically it shows the complex nature of RBAC in Kubernetes. For that matter, any RBAC model, right? This is how it generally looks like. Okay.
Yeah,
and
pause for a moment there. You know, one thing that I always find really interesting about this graphic is this is looking at just a single cluster, right? And
absolutely,
it just shows how insanely complex a single cluster's relationship is from an RBAC policy perspective. So imagine trying to parse through this manually or trying to even frame what you're going to look at. I mean, before we even get into it, just seeing like this mesh of all these relationships, I'm always just blown away that this is just a single cluster. Yeah.
So one thing that I want to touch upon, yes, Jeremy, is Siban talked about the security risk earlier, right?
Yeah.
If you think about the number of connections in this graph alone, here are the potential paths an attacker could take when they compromise even one subject here.
Yeah.
Here are the so many paths that exist in the Kubernetes environment that anybody can take and move across, move laterally, right? So that's why the IAM is very important fabric that any organization has to protect at the control plane level.
Yeah.
Absolutely critical for us to keep it tightened. Yeah, go ahead, Siban.
Yeah. Thanks, Sudarshan. Yeah, so this is a very powerful tool, like as we're showing here. So it's very complex, as we are saying, and what we are doing here is basically like the risky configurations that we talked about, right? So the moment you click on one of the risky configurations, like we discussed about who can exec into pods. Unfortunately, I do not have any such roles at the moment, but we can discuss one more. Who can access secrets, right? So in this case, like, see, look at the complexity of the RBAC system at the moment. And the moment I click on it, look at the clarity. So at the moment, what I say is, these are the subjects. Okay. They can, so this, I'll zoom it a little bit. Okay. So these are the subjects. They have, some kind of access to secrets. Okay. So it's basically like, for example, this is a manager group. It says that manager group can get secrets, watch secrets, and list secrets as well. Okay, so you want to know, okay, who all have secret, access to secrets, and you want to audit it. For example, let's say, okay, manager group should not have access to secrets. Then this particular graph clearly shows you that, okay, manager group belongs here, and you want to basically go back and rectify that, right? That is how it basically helps you audit all these relationships and take necessary actions. Okay, and Sudarshan, you want to add anything here?
No, I think good. I think you're on the, yeah, go ahead, yeah.
Yeah, so we can check one more example. For example, like who can delete Kubernetes events, right? So the flow is basically like, if you think from the MITRE techniques point of view, again, right? So how they do it, like, they get initial access, they try to execute, then they try to escalate the privileges, then try to access secrets. Then one of the steps after that it comes is like they want to delete their footprint, right? The attackers basically want to delete their footprints. That is called evasion, right? So in this case, we want to check, okay, who all can delete events in Kubernetes? Okay, so generally in production, you should not have all kind of this kind of permissions are allowed in your live running environment. So because it helps you audit a lot of stuff. But if at all you have something like this, and then attacker basically can take advantage of that and deletes the footprints, then you basically it becomes very difficult for you to even capture the malicious activities, right? Because you will not have any audit logs. So that is where basically it comes very, very handy. It says, okay, this guy, test user, as pod exec, as part of the pod exec role, can delete events. Okay, this is how, again, like from security point of view, when it comes to access secrets, I gave the example of audit. Now think from the security point of view, how it helps you. It basically tells you from the security point of view as well, this is bad. You have to go back and avoid using this kind of roles in your production environment.
And Siban, do you want to show the on the top on the service account? This is the flip side of the question, right? Given a user or service account, what are the things that a user could do? Yeah.
Yeah. For example, let's say we go to default RBAC. Sorry, I will find one more. Yeah. So this is one service controller, right? This is one service account. This is how it looks like on the UI. So the service controller is part of this service controller role. Okay. So by default, it basically it's a default role, by the way. And by default, it can list and watch nodes. It can get, list, watch services. It can create, patch, update events. There are certain service accounts that that have access to all the resources as well. For example, we can go to this one, and I'll just clear this once. And yeah, see. So who has privileges on all resources? Okay. So here we can go to one of the service accounts, query.sa. So this guy has access to all the resources. Okay. So on all the resources, he can get and watch, but still it's kind of a privileged account. So now, if one attacker comes into your environment and he gets the privileges of this particular service account, then it becomes a very powerful user, right? Because the attacker has a lot of privileges of this service account itself, and in return, again, that leads to a lot of impact. Probably it can damage a lot when it comes to your cluster.
So Siban, can we query more around this data? Is there a way to do it, basically?
Absolutely, absolutely. See, I'll show you the power, right? So by default, we have 5 out of the box risky configurations. Okay, and of course we'll be enhancing this thing. But at the same time, we have something called investigate. This investigate here, and again, the stop filters that you see together, that becomes a deadly combo. It's a very powerful combination, right? So let's start with one of the use cases. You want to see, okay, on a particular resource, who all have, who all subjects have any kind of access, or whether they have just view only access or whether they can do any kind of manipulation, right? For example, let's say you want to find out who all in this cluster contest QA have access to secrets, any kind of access for that matter. Okay, we just go here and select secrets. Give me 1 second. Yeah, we have secrets. So now it says that all these users, I'll just clear this one once. This actually is a QA environment, so.
Yeah, and feel free to zoom in a little more.
Yeah.
Yeah, just to give a little more clarity.
Yeah, pick another investigation if you want, other than secrets.
Yeah, I'll just clear it again and just go to this one, come back. Yeah, you can go to config map for that matter.
Yeah.
Okay. So now it basically says that, okay, all these users, they have access to config maps. Okay. And
Yeah, you have the users on the left and you show the actual
yeah.
policies that lead to the access to the config maps.
Yes.
Yeah.
Yeah. So it's basically like if you see, right? So what I was interested in, I want to see, okay, who all can access config maps, right? So now it says that, okay, these are all the users on the left side. Okay. Those can be service accounts or users or groups, right? They have access to config maps. Okay. So for example, here basically they can get config maps, here also get config maps, here basically like get list, watch config maps, etc. Now you want to, for example, let's say focus on one particular user, right? You want to see, okay, which user, you want to see, okay, if this particular user has access to config maps or not. So you can go here and select one particular user as well. You can see, okay, this user kubestore collector, as part of this kubestore collector roles, has access to config maps, and also it has access to all the resources, right? So it kind of completes the story. The story you started is who all has access to config maps. Now you're basically trying to see, okay, probably kubestore collector should not have access to config maps, right? So then you want to basically select that user and go deep again, like in another step of drill down. You see, okay, out of all the users, whether kubestore collector is one of the users that should actually have access to config map or should not have access to. If at all it has access, like whether it should have the relevant accesses. Right? At the moment it says that all permissions, right? Was that intended? Like, do you want to basically audit it as part of this? Like we are auditing at the moment, right? Or you want to basically trim some privileges. You want to provide it only view only access. It's a hypothetical situation. It's like default service. I mean default user. But I'm just giving a hypothetical situation. For example, let's say you want to provide only view only access to config maps for this user. So this particular view gives you a lot of inputs like that. It provides a lot of input saying that, okay, as part of your auditing mechanism, it provides you, okay, these are the different scenarios where you can improve your RBAC security model and go back, change this particular thing and provide only view only access instead of providing all accesses to config maps. That is eventually will lead to your least privileged model as well.
This is fantastic, Siban. I want to say thank you so much for kind of starting with that story of the major complexity and visualization we saw. And I feel like by the end of this, we're seeing quite a few different ways to really parse out these risky configurations. Either look for the starting point of what the investigation privilege is, or the starting point of what service account we want to look at. I think you did a fantastic job kind of walking us through that use case as well. So I'm happy to kind of take back the screen if you want to stop sharing, and we can open it up for a couple questions for Q&A. I've seen one come in during the call. So yeah, feel free to stop sharing and we can open it back up to the discussion just for looking at the clock right now. Yeah.
Okay.
Awesome. And while you're doing that, I'll go ahead and pull up the questions. Let's see what we got. Oh, okay. Yeah. So, Siban, I don't know if you want to kind of keep this conversation going, but one question was around the source of this RBAC data. So where are we grabbing this data from? And, does Kubernetes have extensive RBAC API call data that we're using, or what's the source here?
Yes, we are using API. So basically like RBAC, like everything is configurations, right? So these are all YAML files. So we are using API to basically get all this RBAC information, all the role information, the user information, and the resources information. And yeah, that is how we basically get all the data and display it on the UI.
That's fantastic. Yeah. And then just kind of a final thought, Sudarsan, you've had so much experience in identity over the last couple decades. I'd love for you just to share your final thoughts around what excites you about this RBAC solution that we're creating. And yeah, just share your final thoughts.
Yeah, no, absolutely. I mean, identity is the key attack vector. No matter what asset you're trying to protect, it's one of the fundamental layers that attackers go after. Whether it's a cloud, Kubernetes, it doesn't matter, right? And protecting that identity is very important for any organizations. To protect it, you need to have visibility first, right? So first we provide the visibility, whether it's an RBAC or any access control model. On top of that, we want to highlight some of the key risks so that organization can go and try to address those risks immediately. That's the most important thing that you have to look at when it comes to protecting identity layer for Kubernetes.
That's awesome. Well, thank you so much, everyone who has joined us this month. Obviously, Siban, Sudarsan, we all love talking about this stuff. So feel free to reach out after if we didn't get to your question or if you have any thoughts after this webinar. And of course, if you want to see this in person, we are at KubeCon EU this week. And we're also always available online. So definitely reach out, come say howdy, and looking forward to seeing you all next month. Thank you so much.
Thank you, Jeremy.
Thank you, guys.
Thank you, everybody. Thanks.